Hello, I'm Laura Marshall.
And I'm Melinda Rose, and this is Light Matters for March 8th, 2012, our one-year anniversary.
On this week's show, news from the Optical Fiber Conference, a laser cools by warming, the Mars Imager turns 10, and we introduce you to our latest iPad 2 contest winner.
The Optical Fiber Communication Conference, OFC NFOEC, is taking place this week in Los Angeles. Among the research presented there is a discovery at UC Berkeley that the wonder material graphene makes an excellent active media for optical modulators. Graphene-based modulators are expected to significantly enhance ultrafast optical communication and computing. Well, you just returned from a whirlwind trip to LA?
Yes, I did. I attended a day-long workshop on opportunities and trends in manufacturing put on by OIDA. In 18 presentations plus 2 panel discussions, we got to hear from industry, government agencies, the financial community, and even academia. Ganesh Gopalakrishnan, OIDA's Executive Technical Director, said a palpable trend is moving from manufacturing to services. Basically, competitive companies have to look beyond just the products they make. Erica Fuchs of Carnegie Mellon discussed her group's research into the effects of moving offshore. They found that emerging designs are significantly more cost competitive if manufactured within the U.S., but established designs are far more competitive when made in East Asia.
And you can visit Photonics.com for more on the conference, including news from Oclaro, JDSU, IPG Photonics, OpNext, and Neo Photonics, among others.
A new way to cool semiconductor membranes paradoxically uses lasers to bring their temperature down by heating them up, paving the way to efficient cooling of components for future ultra-sensitive sensors and quantum computers. Researchers at Niels Bohr Institute developed the new cooling method by making semiconductor nanomembranes. The membranes interact with laser light in such a way that the certain oscillation mode is cooled down to minus 269 degrees Celsius from room temperature due to the complicated interaction between the optical resonances, the membrane movements, and the properties of the semiconductor material. Even though the membrane as a whole is getting a little bit warmer, the membrane is cooled at a certain oscillation, and that cooling can be controlled with laser light. The discovery could lead to the development of new sensors for electric current and mechanical forces. They might even replace today's expensive cryogenic cooling, which could result in extremely sensitive sensors that are limited only by quantum fluctuations.
NASA's Mars Odyssey has been orbiting the red planet for 10 years now. Its main camera, the multiband THEMIS, or Thermal Emission Imaging System, began scientific operation on February 19, 2002. It has circled the planet nearly 45,000 times and has taken more than 500,000 images. THEMIS combines a 5-wavelength visual imaging system with a 9-wavelength infrared imaging system. By comparing daytime and nighttime infrared images of any given area, scientists can determine many of the physical properties of the rocks and soils on the ground. Some of the scientific results documented by THEMIS over the past 10 years include discovering CO2 gas jets at the South Polar Ice Cap in spring, discovering that the large impact crater Aram Chaos once contained a lake, and discovering a more evolved form of volcanic lava not previously known to exist on Mars. Both Odyssey and THEMIS are in excellent condition and are expected to function for years to come, NASA said.
I'm happy to announce we have a winner for our recent iPad 2 giveaway. You may recall we were asking you to share a link to Light Matters with a friend. That's just what Brian Grenke did, and he is our winner. Melinda, you talked to him the other day, right?
Yes, he was very excited to win, and he uses photonics every day in his work at the Chrysler Proving Grounds. Here's some of our conversation. Well, welcome, Brian, and congratulations on your win.
Well, thank you very much.
Why don't you tell us a little bit about yourself, what you do, where you work?
Well, my name is Brian Grenke, and I work for Chrysler at the Chelsea Proving Grounds, where we do all of the crash testing on Chrysler's vehicles. In analyzing these tests, we have to know exactly how things are moving within the vehicle and the vehicle itself. So we use a series of high-speed video cameras recording at 1,000 to 3,000 frames per second. And then we have a laser system which maps out the aberrations in the camera lenses. And these are used to make post-test corrections to the videos. And then all of the data from those videos feeds into one software program that we developed in-house and gives us a 3D motion analysis of all of the targets within the test.
And you happen to have the distinction of joining us on our one-year anniversary show. So why don't you tell us how you feel about Light Matters?
I think Light Matters is great. From the first time I saw it, I started getting ideas on how it could be used within my department. And really, I mean, it reminds me most of a small trade show where all of the best products are put right on display right in front of you.
Great. Well, thank you very much and congratulations, and enjoy your iPad. Now you can watch Light Matters when you're on the go.
Oh, thank you. Thank you very much.
I hope Brian enjoys his iPad. And I cannot believe it's been a whole year since we've been doing this show.
Yeah, it's been nice to see awareness of the show increase over the last 6 or 8 months as Laura and I travel around the country and attend shows and conferences and meet some of you.
Yeah, and the recognition is really nice, but gifts would be even nicer.
Yeah, perhaps some small unmarked bills. Well, that's it for this edition of Light Matters. As always, we'd love to hear from you. Tell us what you like or don't like about our show. We welcome your comments and suggestions at lightmatters@photonics.com.
You'll find links to share and subscribe to Light Matters by clicking the Share with Friends button on our video player.
Thanks for watching, because it's only 5 minutes to enlightenment.
We use light in different, basically, ways. One of them is we use it for basically data storage, holographic data storage, and also we use it in medical application, military, and also basically fun, such as video players and all those things.
This is one of my wife's latest ones. It's my daughter, Madison. This is Madison. She's the one that you saw on the rug. This is my wife, Tiffany.